在这边指出这张贴纸，因为其实 GIS 在全球推广至今年刚好是第25年，那所以我想我们在座各位也应该都是业界或者利用 GIS 在我们生活当中的每一天。那请各位举起这张贴纸，那我们一起来说一声 GIS 快乐。3、2、1，好，谢谢各位，谢谢。
Sorry, there's some technical issues. One moment.
There we go. Okay, start.
Good afternoon, everyone, and thank you for joining us today. The purpose of this session is to share knowledge, insights, and experiences. We also wanted to share some of the work and latest updates which we are doing at Esri. Before we begin, I wanted to introduce myself. My name is Johannes Worm, and I'm part of the business development team at Esri, looking after our APAC operations.
And I'm Craig Pittman, a solution architect in Esri's office in Singapore, looking after our technical designs for partners and customers across Asia Pacific. We're also joined today by Xian, Thomas, Saga, and Ian, who many of you may already know as part of the Esri family.
We are all united here today because we share a common passion, GIS. We are addressing some of the world's largest problems. And I wanted to take the next couple of minutes to share some of the great work which GIS professionals in Taiwan and also around the world are doing across their various fields. Let's take a look firstly at climate change and environmental monitoring. You are doing some great work in understanding the current and future state of our planet. Here we see the Climate Assessment Atlas in the USA. This tool provides the public with insights into how climate change is affecting homes and businesses. In the center here, we see the World Resource Institute, which is analyzing forest loss impacts in Southeast Asia. And closer to home, I'd like to draw your attention right here in Taiwan to how the Ministry of Environment is analyzing air quality through their air sensor networks. These are just some of the examples in which we are using to contribute to our world through GIS. Natural resources across the spectrum are also being managed with GIS. I wanted to point out the great work being done by the Forestry and Nature Conservation Agency in Taiwan, which is analyzing forest fires across the country. And in the bottom left here, we see the Ministry of Agriculture, which has developed a platform to identify invasive species and how they're impacting the environment. One of the foundations for civil societies around the world is land information. Being able to track parcel ownership and manage land records ensures effective land governance and sustainable development. These are just a few examples of how local governments and cities have implemented parcel zoning and are using this information to create accurate land valuations. You see this being applied by the Ministry of Agriculture, who are using field surveys on the ground to capture images, capture land parcels, and cross-reference them with their systems. GIS is also being used in urban planning and regional planning. We are seeing many cities use GIS for key initiatives such as zoning administration, building reviews, and urban design. One great example here is by a university in Paris, which is using complex models to understand the student housing and to help them with student housing planning. And on the right, here in Taiwan, we see a 3D digital twin of Taipei, Beitou, and Xiling Science Park, which has been designed by the Urban Planning Bureau. Transportation is becoming crucial in ensuring that we can move around safely. By capturing key information such as traffic, road accidents, and also highway fatalities, this serves as a powerful tool for better decision-making. One of my favorite examples is here by the Civil Aviation Administration and Ministry of Transport and Communication. They've actually developed an application and platform for the public which allows them to see where they can actually fly their drone. They can see where they can fly their drone, they can see where the no-fly zones are, and if they do want to fly a drone above 120 meters, they can also apply for a permit. Real-time monitoring enables organizations to respond quickly to changing conditions. And GIS has allowed public works to track and manage their assets across all different types of operations. One interesting initiative I wanted to point out is by the Keelung city government, which has created 3D models of their buildings and has also integrated IoT devices to capture certain information such as energy and also CCTV footage to capture potential security threats. Many of you are taking GIS indoors and mapping out buildings and campuses. Universities across the world are using GIS for infrastructure and also campus planning. We see here in the middle, which is using and has developed an application which provides indoor directions to their students to navigate around their own campus. And in the top right, we see Chonghua Telecom, which has mapped out their green energy smart park. And they've also integrated certain IoT devices to basically monitor consumption of electricity and water within this park. GIS is also playing a very important role in making cities safer and supporting emergency management. They're being used by cities and governments to understand crime patterns, fire incidents, and also real-time threat monitoring. We can see an existing, very interesting example here by the City of Chicago Police. What they are doing, they're actually capturing all the different crimes in certain areas, doing analysis to see where they can allocate their resources. And the preparatory office of the National Railway Museum, which is using AI and GIS to detect people's movements and then displaying it via a heat map on a map. Your work is also playing a major role in planning for forecasting of impact of disasters. This is especially critical here in Taiwan, where earthquakes, typhoons, and landslides are very common. GIS is being used to map vulnerable areas, predict the potential impact of these natural disasters, and also enables resource allocation for disaster preparedness and recovery. Taiwanese residents are also helping out. We can see here with the National Science and Technology Center for Disaster Reduction. They have allowed residents to actually use the Line social media application to upload pictures of potential disasters, which helps the center provide early warning alerts for upcoming events. Since the COVID-19 pandemic, there has been an increasing need to track medical outbreaks or analyze health issues affecting large populations. Real-time monitoring of dengue and COVID-19 has proved an invaluable tool to stop the effort and reduce the spread of these infectious diseases. The map in the center by the CDC shows cancer clusters in relation to public health. And at the bottom left, we see a researcher from Fengsha University, which has built a data connection to actually showcase the number of reported COVID cases in Taiwan and across the world. I would also like to touch upon how many organizations and local governments are using GIS to engage with the public. In Japan, for instance, GIS is being used to show visibility across wheelchair accessibility across the country. GIS is also being used for open data and services. Governments are creating their own platforms where the public can upload their data. One of the interesting examples is from California. The governor actually carries around with him an iPad wherever he goes. What is on this iPad? This iPad uses GIS to track several key areas and monitor 28 real-time maps. These maps include wildfires, unemployment, natural disasters, and critical developments happening in his state. This allows him to fully be up to date with what is happening in his state. And the Keelung city government is using story maps to show the public where there are bike roads, hiking paths, and recreational activities. GIS and your work are already contributing and playing a significant role in our collective future. However, we need to do more to address the big challenges we are facing. Your work as a GIS professional is part of something much larger. It's influencing and creating the future of our planet. You and the work that you do are essential for creating a sustainable future. I would like to close this section off with a quote from Ralph Waldo Emerson, who is a 19th century philosopher. He said, "Among the map makers of each generation are the risk takers, those who see the opportunity, seize the moments, and expand humanity's vision of the future." We at Esri believe that as a collective group, we can leverage the power of geography and GIS to do exactly what Emerson said: unite our world and create a better future. Next, I would like to talk about Esri's work and share with you our vision and what we've been up to over the last couple of years. This is about creating technology which helps you do your work better, and is focused across a technology called ArcGIS. ArcGIS is by design a comprehensive geospatial platform designed to create robust systems and solutions. It boasts foundational capabilities in areas such as 3D, imagery, and analytics, and of course, mapping and data management. The platform is accessible in various formats: software, SaaS, and PaaS. For instance, many organizations are adopting a cloud-first or SaaS strategy to enhance their business capabilities while minimizing their infrastructure cost. Some are using and beginning to explore containerization and microservices. Today, users expect seamless access to data and applications wherever they are, be it at home, office, or on the ground. And we are striving to do that. Although PCs, laptops, and desktops continue to be utilized, the landscape is shifting. We are moving from a traditional desktop-centric workflow to evolving into a more integrated ecosystem. So what does an ecosystem like this look like? ArcGIS is designed to support everyone, from GIS and IT professionals, knowledge workers, mobile workers, to executives, and also to the public. ArcGIS, in summary, is designed to support individuals, organizations, and entire communities.
Over the last decade, we have been working on accommodating these expectations and have been rebuilding our Esri technology with a new architecture, a web GIS architecture, and the notion of thinking of ArcGIS as an enterprise system. ArcGIS serves as the foundational platform, but also serves as a tool to deliver systems to users. When we talk about systems, it is used to describe a set or a subset of ArcGIS capabilities and components, apps and content, and how they are architected to support workflows, business requirements, and deployment preferences. Here are just a few generic names for the type of systems that our customers, partners, and distributors have implemented in their organizations. There are many types of systems. And whilst GIS was once just a mapping system, so many organizations now utilize powerful ArcGIS capabilities for their imagery management system, location services system, mobile operations management, and big data analytics. And perhaps some of you are seeing these systems become increasingly interconnected within your organization and to other organizations as they share services and data. Similarly, GIS was once the exclusive domain of GIS professionals. However, with GIS present in so many different systems, we are seeing so many different audiences with access to ArcGIS. This includes equipping executives with the authoritative and real-time information to enable better decision-making. Lastly, as we all know, the number of electronic devices and types of devices has increased exponentially in recent years. It's not uncommon today to own half a dozen different devices and be accessing your work email on a desktop during the day, on a tablet on your commute home, mobile device when watching TV, or perhaps even read out to you from a smart speaker whilst you do the housework. Perhaps some of you are even reading emails and messages on an AR headset. Now, this is similar to how we see GIS systems evolving. Esri has evolved too. We see the traditional devices, but also recently have seen 3D visualization and simulation through VR and AR. We also see systems being fed information automatically through remotely sensed data and IoT devices. In the past 10 years, Esri has evolved our licensing model from the traditional one individual, one system, one device, one license. We have introduced the concept of an ArcGIS identity, where each individual in an organization is enabled through a single license, and it is automatically provided access to the system regardless of which device they are using. Recently, we have fine-tuned these licenses and expanded their capabilities even further, without requiring additional purchases. We have also listened to feedback. We heard that customers wanted these user types further simplified and make it easier for more members in an organization to get access to GIS. So, in the Creator, Professional, and Professional Plus, we grouped the apps and capabilities that GIS professionals need every day. And in particular, the Creator user type now includes ArcGIS Pro Basic, which is a significant benefit. And you can add additional users to your organization: viewers, contributors, and mobile workers. You could think of these as collaborators within the organization, and they can boost your productivity and expand the reach of your GIS. Each of these new user types, from viewer up to Professional Plus, receives incrementally more functionality. In doing it this way, we will significantly simplify access, licensing, and administration of ArcGIS in your organizations. ArcGIS includes many apps. As I mentioned apps before, and many of you use today, many of these apps are provided out of the box on desktop, mobile devices, and so on. The use of these has exploded in recent years. Many of you are using these apps to enhance your work with functionality and to provide exceptional user experience and access to your maps and data.
ArcGIS also includes a massive amount of content available in the Living Atlas, which has thousands of created layers and millions of user-shared content. These are just some examples of the new and improved areas. Over 70 million data sets and maps have been shared for other people to use, and this is constantly being updated every day. We have made some improvements this year in the Living Atlas, which now includes 3D base maps based on OSM data and enhanced with additional commercial data. This is an example of the enhanced 3D base map, and here is an example here in Taichung, in Taiwan. It's the foundational content for 3D GIS for the entire planet. ArcGIS is also open to developers through our APIs and SDKs. This has allowed them to extend and automate ArcGIS as well as create new applications. Developers can extend ArcGIS through the ArcGIS Pro SDK, which can be used to build custom apps, add-ins, and tools for ArcGIS Pro. Through scripting and the Python API, you can automate map creation. And through our client-side APIs and SDKs, you can build applications. Together, these tools expose powerful location tools and services to developers. So let's discuss the next elements and our location services. They are available on a consumption basis, allowing you to leverage these powerful capabilities as and when you need for your solutions and applications. This includes everything from base maps, data hosting, data visualization, and also our commonly used capabilities such as geocoding, routing, and also places. These services can be deployed across the web, mobile devices, and desktops, and even system-to-system integration. What I also wanted to share is that base maps, data hosting, visualization, routing, geocoding, spatial analytics are tools which can be used online and offline, indoors and outdoors.
So we've just spoken about how ArcGIS provides data for your GIS, but it also integrates all the data that you have within your organization. You can see many different types of data sets on this screen here. And ArcGIS abstracts all of your data into maps, layers, and 3D scenes, and makes them available and accessible throughout the system, regardless of the device being used to access it. So you could think of GIS or location as being the ultimate integrator of information. It doesn't matter if it's a spreadsheet or a tabular data set. Everything is connected through location and presented in a uniform way through the ArcGIS system. I want to highlight one of those types of data, in particular, CAD and BIM. In this unique collaboration with Autodesk, in our strategic partnership, it is more than just reading data. It involves connecting engineering data, systems, and workflows, and allowing users to directly access CAD and BIM files for analysis, visualization, and sharing throughout the system. In other words, it allows Autodesk users to become part of the ArcGIS system and transforms engineering workflows from planning through to project delivery and beyond. But ArcGIS also integrates with many other enterprise systems, including IBM, Salesforce, Adobe, AWS, SAP, and more. And we do this not just for interoperability, but to geo-enable these other business systems and workflows and integrate geographic thinking and the power of location everywhere. This concept is best expressed in our work with Microsoft, where today Esri's mapping, geocoding, and spatial analysis services are available to the whole Microsoft 365 portfolio of apps. Now, if you think about inside your own organization, it is quite likely that everyone is already equipped with Microsoft 365. So your work as a GIS professional and the geospatial capabilities of your organization can be accessed by workers everywhere by leveraging ArcGIS in Microsoft 365. In addition, we're also proud that Microsoft has chosen Esri as their spatial provider for Microsoft Fabric. Microsoft Fabric is their new software as a service solution for data analytics. Esri has partnered with Microsoft to deliver a seamless set of mapping and spatial analytic experiences across the Fabric platform. Okay, so we have talked about how ArcGIS integrates with other systems. Now let's talk about ArcGIS itself and how it is advancing. With more than 2,000 staff across the globe in Esri's product teams, we continue to evolve the capabilities of ArcGIS every day, and we improve the quality and performance while incorporating many new innovations across our entire portfolio. Today, we will highlight some of the great advancements we've made this year. In our first area, I'd like to talk about how many of you already deploy ArcGIS as an analytics system because of its powerful spatial analysis data science capabilities. We now have over 2,000 geoprocessing tools, models, and methods that many of you already use to solve all types of problems. And we're introducing new innovations in every software release. The product teams that I work with have done a lot of work on data engineering to prepare data for analysis and advancing spatial statistics with machine learning. So GIS professionals and data scientists are accessing these capabilities through the Esri apps, but also with Python, notebooks, and Model Builder. And Model Builder is soon coming to the web. So let's look at an example of the advanced analysis possible with ArcGIS. This is flood simulation from within ArcGIS Pro. Using a digital terrain model with an embedded physics model, we can simulate the amount of rainfall to see where the water is likely to accumulate and where flooding may occur, so we can better understand the potential impact and plan accordingly. Building upon that, ArcGIS is also being enhanced with AI. Beyond our investment in spatial analysis and data science, we are doing this in two ways. The first is GeoAI. We've been doing this for several years now, building upon our geoprocessing tools and background, but we're now integrating machine learning and deep learning techniques to advance spatial analysis even further, to abstract information from data, and to automate tasks that once required extensive manual efforts, such as feature extraction and object detection. The second area is with AI assistance, where we can leverage large language models so you can talk or type with the software, ask questions in a natural language, and get answers. But we also want to add these assistants for you and into your work for mapping, analysis, and navigating your GIS. We continue to advance the GeoAI tools and models in ArcGIS. GeoAI brings together AI with the science of GIS to extract information and perform analysis. So with our out-of-the-box AI tools and models, you can extract features from imagery, LiDAR, and videos. And then using these tools, you can find patterns, detect anomalies, or extract insights from the resulting vector data or unstructured text. Included in ArcGIS now are more than 70 GeoAI models that are ready to use for many different industries. And you can download these models to quickly start detecting, classifying, identifying, and extracting information from your data. We have seen over 500,000 downloads of these models, and people are using them actively every day. They are lowering the bar to entry into exploring the world of AI and to advanced analysis. The idea for these GeoAI tools is to automate, but not replace, to automate your workflows, to create new data for other parts of your systems. So I'd like to introduce our local subject matter expert, Saga, who has focused locally here on GeoAI for the past 3 years.
大家好，那接下来由我来跟大家介绍几个 AI 在 ArcGIS 里面的功能。那刚才 Craig 有讲到，就是在 AI 的部分，有分成2大部分，一个是GeoAI 的部分，那另一个部分是属于 AI 助理。那首先我们来看一下在 GeoAI 的部分。不晓得大家有没有一个印象，在今年年初的有一个新闻，就是说美国一个大学生找到了某个国家的100多个飞弹发射井，这个是在美国军方一直找不到的东西，但是他就是用这个所谓GeoAI的功能。那今天 ArcGIS 把这个功能把它简单化了，大家都可以很快速或者是很简单的去应用这样子的功能。那这样子的功能基本上有几个基础的步骤了。那第一个是找到你的训练样本，就是你想要找到什么样子的目标，那首先你需要找到几个样本来让 AI 去做一个训练。然后接下来是把你找到的标注完了之后，把它输出成一个一个的训练样本，然后丢到模型里面去做一个训练，之后就可以做一个推理产出，然后去做一个大量的产出的动作，得到你想要的结果。那这个步骤呢，其实你可以省略一些啦，在 Living Atlas 里面，在 ArcGIS 的 Living Atlas 里面，已经有提供超过70个预先训练好的模型，可以供大家去选择，可以下载，可以去使用。好，那接下来我们来看一下实际使用的案例。在这里面呢，就是我们想要从 ArcGIS Online 所提供的影像里面，然后去使用 Living Atlas 里面提供的TestSend 的预先训练好的这个模型，来去找到在影像里面的飞机。好，那接下来这边就是在找搜寻我想要使用的这个模型的部分。好，那里面提供很多，然后你可以利用文字的方式去做一个简单的搜寻，然后选择了之后，然后告诉他，我要找的目标是什么？比如说我要找的是飞机，然后的样本的大小大概是多少？把这些参数设定完了之后，按下执行，你就可以在网页上面去做 AI 训练的动作，得到你的结果。我在 ArcGIS 里面有两个方式，你可以得到你想要的这样子的一个 AI 的训练，或者是得到训练完的结果。一个是在网页上利用 ArcGIS Image Server 来帮你去做计算，另外是透过 ArcGIS Pro， 那这个计算则是由你本机的计算能力去做这样子的计算。那我们同样的利用这样子的方式，我们自己也尝试了去搜寻，比如说飞机的部分， 好，那我们去找到，比如说这样，在这个是飞机坟场的部分，我们找到了相当多的飞机在这上面，这是我们执行完的成果，就是在紫色的部分，把它放大上去，放大进去看了之后，我们会看到它的确帮我们找到了许多辆的飞机在这上面。那在其他的机场上也是一样。然后我们值得说明的是，在上面你会看到会有一个信心的分数。那这个信心分数当然，数字越高，代表说，你可以信任它的程度就会越高。但一般来说，在大于30的数字的时候，就已经可以满足我们大概90%的需求，就是它的正确率大概会有90%左右了。那必要时你也可以在做筛选的时候，你可以把这个值去增加、放大或是缩小，以得到那个结果是符合你想要的为主。那这是新宁机场，然后这是佛山机场的训练结果。那训练完的结果还可以用仪表板的方式来做整个呈现，看有各个机场有多少目标，或是总共的目标有多少，平均的行星数值是多少等等。那关于GeoAI的部分，我们在后续的场次会有再进一步的做介绍。那接下来我们来看一下 ArcGIS 上面的 AI 助理的部分。那刚才 Craig 有提到，这个是由大型语言模型，就是 LLM 的部分，以及生成式 AI。大家应该或多或少都有用过 ChatGPT 嘛？那这个的界面或者是使用方式，基本上就跟 ChatGPT 类似。就是你只要使用你一般你在跟大家对话的时候使用的语言。你只要告诉电脑你要做什么事情，那它就会相对的给你一个回应，而且是用你知道的语言来回复给你。那在 ArcGIS 的 AI 助理上面，可以协助你进行，比如说智慧制图，或者是文件的寻找，甚至产出。那以及 ArcGIS Pro 上面有提供。然后在 Survey123里面，目前我们也实做了一些可以用生成式 AI 的方式产生的调查。那首先我们来看智慧制图的部分。这是在 Map Viewer 上面，大家应该大部分都熟悉这样子的界面了。如果大家有用 ArcGIS Online 或者 ArcGIS Enterprise 的部分，这是 Map Viewer。当我们把地图载入进来的时候，我们想要让它去改变我们看到的样式的时候，通常我们会选择一个栏位，然后根据这个栏位它是数值还是文字，然后再去调整这个数值或者是文字给显示的方式，因为这两种方式显示的方式是会不一样的。以数值来说，它可以用颜色的深浅、符号的大小，甚至这种点密度图的方式来呈现这个数值的大小。那如果我们要用 AI 的方式呢？那下方你会看到下面这个区块已经有提供一些可以让你直接点选的，就建议你可以使用它的方式，或者是中间有一个或者是它中间会有一个区块可以去，或者是它中间会有一块可以让你去输入文字的地方，然后那一块文字就是你可以告诉他，比如说我要它是利用人口的多寡去产生一个显示的方式。Yeah. 稍等我一下。我们重新再播放一次。好，待会这中间会有一块是可以让你输入文字的地方。那当你输入文字，比如说我告诉他我想要 人口，依照人口，然后用颜色来去做一个呈现的时候，我只要告诉他，我要用人口，然后来决定我的颜色的深浅，然后它就会帮我自动的把我的地图换成我想要的方式。然后它会自动帮你选择栏位。如果你的资料，你的栏位有告诉他，比如说你在 ADS 上面可以注明说，这个栏位是人口，或是那个栏位是比如说房屋的价值，或者是它是空屋等等，反正你可以注明，让你的 AI 可以辨识这个栏位就是你口语化叫它做什么事情的时候，它要使用的栏位。好，那现在中间上面那一块就是让你可以去输入的。那就根据，反正就是我们直接日常用语是什么，我就直接告诉他。比如说我现在要产生一个房屋价值中位数的这个数值来呈现，那它就根据这个房屋的价值的数字的大小，帮你去产生。它预设，因为我没有告诉他我要用什么样子的方式来呈现，所以它预设就直接用颜色的深浅来代表这个房屋的价值。那中间有一个 Customize 的这个按钮，你也可以点选进去改成你想要的。它先初步帮你产生一个，那接下来你一样是可以去改，比如说它的价值的分类，那个颜色深浅的分类点在哪里，你可以去调整。那或者是我的颜色的色票，或者是颜色要深浅的深是哪一个颜色，浅是哪一个颜色，这个都是可以再手动的去调整。那除此之外，我还可以再告诉他，再帮我产生一个利用人口数，然后用 size， 所以他待会就会，因为我已经告诉他我要用大小，所以他就会产生一个用符号大小来呈现我人口数多少的显示的方式。那同样的，这个按钮也有一个按钮可以让我再去进一步去修改这个大小的调整，或者是颜色的调整，这边都是可以继续去做调整。然后中间你也看到它目前用的栏位是哪一个，它已经帮我们直接用它可以辨识的栏位去进行。好，那接下来我们来再设定一下，比如说教育程度。那这个教育程度，因为它是文字的栏位，所以它里面就是根据这个栏位里面有哪些值，它就直接用那个 Unicode Value 的方式去产生那个符号。你可以在图例上面看到，待会你可以在图例上面看到，不同的图例、不同的颜色，它是代表什么样子的教育程度。那同样，它也是可以在 Customize 这边可以去做一些，比如说颜色的调整。那由于因为它是文字的方式，所以它就不是像数字那样会有一个渐层的颜色帮你去产生，它就是比较不一样的颜色。你可以看到这边一样，你可以去做一个修改的动作。好，那接下来我们会再尝试的用另外一种的显示方式，对同一份资料。比如说我们显示在这个区域的，就是空闲的房屋，然后用密度图的方式，点密度图的方式来显示。那它就会根据你的指令，然后把这里边的资料去做密度图的显示。好，从这边你可以看到，我们已经把这里面产生了很多种图样。然后呢，更厉害的是，我可以结合不同的栏位，比如说我想要看到，房屋的价值跟余屋的数量，它们之间的关系是什么，我就直接在这边说我要看它的关系，那它就会帮我产生这样子的一个图例。那你会看到左下那边有一个它的图例，越接近黑色表示它是房价越高以及余屋数越多的。那越接近白色的那一端是表房价越低，而且余屋数越少的。那除此之外，我们刚才已经产生这么多的显示方式，可以随时点回去，就可以去做切换。这个记录保留的话，你可以随时可以切换回去之前的显示方式。所以我可能还要再看回去之前，比如说房屋价值的时候是呈现的数值是怎么样，以及刚才的余屋数的呈现又是怎么样，我可以随时的点回去看。 那刚才讲的是在网页上面的智慧制图，那在 ArcGIS Pro 上面，它同样有更多的功能可以让你去使用。比如说大家知道 ArcGIS Pro 里面有很多个工具，那有时候我可能想要做某件事情的时候，我不知道要使用哪一个工具来用，那这时候你就可以用它个 AI 助理，告诉他我想要做什么动作，那他就会告诉你说你可能可以用这个工具来执行。那或者是说一样，我直接告诉他我要增加一个图层，我要缩放到哪个地方，配置显示的方式就跟刚才智慧制图一样，以及我可以筛选资料表中的资料，甚至它可以帮我们编写一些SQL的指令去筛选资料。好，那或者是我可以把整个动作合并起来变成一个工作流程。好，我们简单来看一下在 ArcGIS Pro 上面。
The assistant asked me a question. How can I help you today?
我们可以简单看一下在 ArcGIS Pro 上面可以做的。就是我们先选择我们要哪些资料，我告诉他我们要从哪些资料去产生。那目前图上面看到的是中间红色的那一块是在美国容易产生龙卷风的一个区块，所谓的龙卷风的廊道。然后呢，我现在想要让它，我告诉他说，我想要让它输出，在1990到2010年之间，龙卷风比较大的数量，那几个比较强大的龙卷风的资料出来，让它帮我筛选出来，那它就会自动帮我去产生一段的SQL的指令啊，去筛选这两份资料中间符合这个条件，然后它就会把它跑出来。好，那这一段就是在选择，因为我有两份资料嘛，一个是龙卷风的资料，一个是这个龙卷风廊道的这个资料，然后告诉他我要找到在这中间这个红色的范围里面比较强大的龙卷风的资料出来。我在1990年到2010年之间，2020年之间，所以它就会帮我产生一个，看上面它就会帮我产生一个 SQL 的指令，然后我可以把这个图层把它加到地图上面去，那这是在 ArcGIS Pro 上面可以使用到的功能，而且我只是口语化的跟他讲说我要强的台风，抱歉龙卷风，然后他自己会在那个会有的条件里面帮我指定，比如说这个等级是3级的，3级以上的龙卷风帮我筛选出来。那当然这个SQL 的语法你还可以再去做调整，手动还是可以调整，只是说它已经先帮你产生了一个语法出来。那接下来是Survey123的助理，应该蛮多人都有听过Survey123了，它是帮你产生一个调查表的一个问卷调查的一个工具。那以前大家在产生的时候都是一题一题的自己去产生嘛，那现在你可以利用 AI 的方式，直接告诉他，比如说我要产生一个台风的风灾的调查、灾损的调查，那它就会根据我的题目去产生一些问卷出来。那这个功能已经目前生成式的调查已经可以在目前的 ArcGIS Online 跟 ArcGIS Enterprise 上面使用。那我们来简单来看一下使用的方式，一样是在下方一个框框里面输入你想要它帮你产生的调查是什么。比如说我输入的是我想要调查一个龙卷风的灾害，那龙卷风会有什么样子的灾害？它就会自动帮我产生这样子的问题出来。那你可以再进一步的提供给它更多的资讯，它就会更接近你想要的问题。然后当符合了之后，你就可以按下产生。那除此之外，它还提供一个功能，就是说，比如说这张照片是龙卷风造成的灾害，我可以把这张照片上传到我的调查的同时，它会去分析这个调查里面可能的灾害是什么，把它变成用文字的方式产生在这个栏位里面。 它现在正在去做一个分析的动作，分析完之后，它就会变成一个语法产生在这里。那这些功能基本上是不一定要用英文来产生的，或者是它产生的功能产生出来的结果也会是中文，在我们的内部的测试里面是可以用中文直接来使用的。那最后一个是在文件助理的部分，那这个部分就是你可以在我们的 support 的网站里面，在右下角这边有一个绿色的按钮，点下去之后，它就会把这个 AI 助理的功能把它打开。它就会把这个功能打开，然后你就可以直接在这边输入你想要查询的东西。比如说我就很口语化的，我要在 Portal for ArcGIS 里面去，我要如何在 Portal for ArcGIS 里面去新增使用者。那它就会告诉你，你有哪几个步骤，你需要到哪里去做什么事情，然后最后你就会成功的去做一个新增的动作。那除此之外，你如果实际上在使用，比如说 ArcGIS Enterprise 上面遇到困难了，我也可以在这边上面直接输入说，比如说我猎鹰服务有问题，我要怎么样去排除这个问题？那它就可以协助你去自助式的解决你目前遇到的问题。那如果真的解决不了，我们就是再进一步的再协助大家去排除你真正的问题。那以上就是我的报告，那还给 Quick。
Saga, it's great to have you working on GeoAI and bringing these capabilities to Taiwan. I'd like to briefly mention that geospatial knowledge graphs are part of our spatial analysis strategy, and they are about mapping and link analysis of relationships of different entities or individuals. This is being used in many fields and applications like supply chain analysis, risk analysis, and crime analysis. They are also a way to map social networks and different relationships that we may not understand until we visualize them in a different way. This has been available in ArcGIS Pro, and now we've introduced Knowledge Studio, a new web application available with ArcGIS Enterprise, so that you can empower anyone in your organization who has a web browser to query the graph and the data and pull out information and intelligence. Next, many of you deploy ArcGIS for imagery and remote sensing work. ArcGIS is a complete system for image management, of course, but also for image and raster analysis and visualization, and increasingly reality mapping. First, ArcGIS supports all types of imagery from different sensors and in different formats. This year, we added support for a few new and important formats. The first is the Spatiotemporal Asset Catalog, or STAC, which is very popular. We've also added support for oriented imagery, 3D satellite mapping, and geospatial video. So if you have a video coming in from a camera or from other devices or from drones, you can stream that video to a number of users, write in and lay it on top of the map or the scene and make it part of your GIS. And of course, you can perform powerful analysis on all types of imagery, from terrestrial sensors, drones, planes, and satellites, to find patterns, explore trends, and forecast and evaluate change. Next, reality mapping is part of our imagery system that we just described. Now, this is about taking a lot of photos from different sources, including drones, planes, and satellite imagery, and bringing them together with powerful algorithms to create beautiful and accurate 3D representations. Let me illustrate this with a video. This video of Stuttgart in Germany shows how you can use reality mapping to create up-to-date, photorealistic, and highly accurate representations of a neighborhood, a region, a city, a state, or indeed an entire country, and use this as a foundational base layer inside your GIS system. With this representation, your GIS becomes more approachable, familiar, and recognizable to everyone in your organization. Now, if we just focus for a moment on drones specifically, many of you are already capturing imagery from drones, and we at Esri continue to support drone data capture. Two products that I'd like to highlight here. The first, SiteScan, which is a hosted Esri software as a service offering. And the second, Drone to Map, which is a popular desktop product for the processing of this imagery. And it creates GIS-ready outputs. So we are seeing GIS and drones being used for asset inspection, including power lines, and reality mapping. Among the many enhancements in our products includes thermal support and a new application called ArcGIS Flight. This is used for planning the flights of drones and collecting drone imagery. Let's take a moment to see what this is capable of. This is the beautiful Red Rocks Amphitheater in Colorado, US. Using a single drone, this imagery was captured and then processed in just a couple of hours to automatically create first a digital terrain model and second, ortho photos and true ortho data that can be draped over that digital terrain model and make it GIS ready and quite attractive. Now, the beauty of this is that many of you are building 3D systems of records, and you can update that 3D system of record with this accessible technology to transform your drone data into 3D GIS. So now that I've introduced our topic on imagery, I'd like to introduce Thomas and Shen, who are going to focus on imagery solutions within ArcGIS.
接下来由我跟大家介绍一下。那我先讲一下为什么我会先讲 Digital Twin 呢？因为基本上我们现在做的很多的资料来源都是透过影像。那在 Esri 这2年并购一家德国 NVM 非常著名的一个测绘公司之后呢，它在 Digital Twin Reality Mapping 的那个技术发展其实进展的非常的良好。那我们的影像来源基本上就会从无人机，然后航照到卫星影像，那这些都是我们的一些基本资料的来源。那透过 Reality Mapping 的处理，我们可以获得比较精准且就便便，我们就可以直接用来做分析。那我们也可以产制更直接式的一个 3D GIS 的一个平台。那在整个 Reality Mapping 的家族里面呢，以 Esri 目前提供，刚刚可以给我讲的，除了中途 Map 跟 SiteScan 以外，我们其实现在有一个 Reality Studio， 它这一套是专门在处理大量航照影像的真实正色，然后产制 DSM 或是仿真模型，基本上都是以 Reality Studio 为主。然后在 Reality for ArcGIS Pro 里面呢，它能处理的就会从无人机影像一直到卫星影像都是在 ArcGIS Pro 里面处理的。那我们这边稍微快，就是在中途 Map 里面呢，我们就以产品命名，你就会发现它其实就是专门在处理无人机影像的。那它现在其实除了真实正色以外，它也是可以处理3D 的仿真模型跟包含 用摄影测量产制的点影资料。那它现在支援了多光谱，还有热显影。不过热显影的部分目前只支援2D。那我们所有的产制的成果都可以直接用 ArcGIS Pro 去开启，然后直接去做使用跟做进一步的分析。然后 Side Scan 一样是处理无人机影像，只不过我们这个所有的处理过程都是透过云端的方式，在云服务里面去做进行处理的。然后刚刚科伟有提到，在无人机的飞行计划里面，现在我们也提供了 ArcGIS Fly， 可以作为一些拍摄任务的飞行航线的设计。那 Reality for ArcGIS Pro 呢，就是我们基本上如果要处理比较大量的影像跟大范围的影像，基本上就会在 Pro 里面处理。但是如果要是比较单纯的，全部都是航测影像的话，有时候我们会建议用在 Reality Studio 的环境下。那以 ArcGIS Pro 里面，因为我们可以搭配很多的地理处理的工具，就那 GP 工具的话，我们可以后续产制完之后，我们可以甚至拉很多 model， 可以做一连串的自动化的一个工作流程。那以我们目前我们会称在 Reality Mapping 的运算核心，我们其实就直接把它命名为 Reality Engine。那相对它们所能产生的产品，基本上就是真实正色影像，然后高层资料，然后点影资料跟3D 的仿真模型。另外，它其实还包含了一个产制，一个叫做 DSM Mesh， 它是以数值表面模型跟真实正色影像去做一个匹配的一个三维仿真模型。不过以我们命名，它会把它称为 2.5D， 因为它其实侧面资料包含的比较少，所以它的仿真模型不会像 3D Mesh 的那么精致。然后这边是我们新的引擎，它做的像我们一般在做 3D Mesh 的时候，在这种比较类似这种高压电塔或者这种比较精细致结构的匹配的时候，其实通常都很容易破图。那经过它这个 Reality Engine 改善之后，我们其实在仿真模型的产制其实有蛮大的改善。然后这个是要跟我们接下来会从无人机影像到卫星影像一些案例跟大家介绍一下。那其实左边其实就是中途 map， 然后就是我们用 local 端的电脑直接去处理无人机影像。然后右边其实 side scan 在透过云服务的方式去做处理。看一下，然后这边的录影画面大概是跟大家讲一下 side scan 比较特别的地方。那除了云服务以外，它除了处理影像，它在整个系统里面，它其实还可以包含你的无人机的机队管理、电池管理，那甚至你的出去拍的一些人员的管理，都可以直接透过这个平台去完成。然后很多专案都会直接保留在上面。然后现在这拍是基隆八斗子的航拍，是我们今年5月跟文大地理的陈志远老师还有他的团队一起去拍的。那我们基本上所有处理都可以在上面呈现，不管是等高线，然后它的 DSM， 或者是它做阴影图，然后这是真实正色的切换。那当然它也可以去直接在 Web 上去呈现它的仿真模型。然后我们其实可以看到，它其实透过现在新的引擎，它在 做仿真模型的那个精致度都其实是非常精致的。像这个是因为它铁皮屋可能是因为台风被吹坏之后，它还是可以保留看到它比较细致的一些结构。然后这也是陈老师他另外也是去拍了基隆太平山那边，也是他产制的一个 mesh。那我们接下来会介绍一下我们跟航遥设分署一起测试了使用了他们的 DNC3影像去做了一些多手的处理。那我们现在这个是一个山区的，大概是2个5000分之一图框的范围，然后我们处理起来，在 Reality 的 engine 处理的引擎里面呢，它其实我们会比较需要比较多重叠率、高覆盖率的地方，所以我们处理完的成果基本上只会保留覆盖率区域比较多的地方。然后左边就是出欧手影像，然后右边是它的 DSM 的。然后我们也用了台北市的27张影像，然后这个是在 Reality Studio 里面处理的。然后我们会看到中间它有一条一条，那个是它设计来我们可以做那种分散式的处理。因为如果我们在处理大范围的影像的时候，其实我们会需要比较多的电脑一起去做运算。它现在可以让很多台电脑去同时去做运算，然后以一块一块的方式帮整个任务把它执行完成。然后它当时也是让它做了一个 DSM 的 mesh 的部分。然后像这是大巨蛋的。然后接下来，因为这是今年4月花莲的大地震，然后我们可以看到左上角是天王星大楼，是地震还尚未倒塌之前，然后它左下角是就地震后它已经开始倾斜的状况之下，然后那时候航遥测分署也是接到紧急任务，叫他们去拍影像，然后就稍微去处理了。像现在目前看到的是用传统的正色影像的处理，我们基本上都还是可以看到房屋有一些侧面的资讯，然后经过 Reality Engine 我们要用 Reality for ArcGIS Pro 处理之后，我们其实可以看到整个建物的侧面，基本上我们把它校正到正确的位置上，那整个那些高差位也到对的位置。我们大概量一下，如果我们看中间那一栋建物的话，它其实它整个建物涵盖到路面上大概4公尺宽左右。我们大概量了一下，就做完出欧手之后，我们可以得到比较正确的位置。然后，如果我们之后再萃取建物框或者是道路线的时候，我们可以比较得到精确的资讯。那我也拿到了，这是 BlackSky 的一个立体对的卫星影像的处理。那我也是透过 Reality for ArcGIS Pro 去大概简单的快速处理，就产生了它那边的高层资料，然后它的真实正色影像跟 DSM mesh。那我们会这样做，原因是有时候我们可能要取得其他地方的高层或者比较精细的一些建物资讯，或者比如说建物高度等等，我们可以透过卫星影像的取得，那我们透过软体，我们就可以去产制，我们可能是要知道那边比较稍微详细的地形跟建物高度等等。那相对我们也透过 Esri 提供的一个 NENS 的一个课程，它这个里面是用了 WorldView 2跟 WorldView 3，大概2-3年之间，然后拍摄一个，这是在圣地亚哥，它的拍摄圣地亚哥大概都有重复到一个相同的区域，然后它透过因为拍摄时间不一样，所以它有一些角度，然后又有一个重叠区域，所以我们可以透过这样的方式去产生它的出欧手影像跟产制那个比较精细的，就是透过卫星影像产制比较精细的那个三维模型。那我们整个 Reality Mapping 家族的优点其实就是它可以帮我们缩短3D 产制的一些时间，那我们也可以透过 GP Tool 去做一些自动化的一个工作流程，然后产制的真实震慑影像 3D 影像基本上是非常精确的。那它整个不管是你在 ArcGIS Pro 或者是 GeoAI Studio 或者中途 Map， 它整个你在处理资料的过程其实是非常容易上手的。那当然我们产制的所有资料都可以在 ArcGIS 的所有产品线去做呈现，然后当然它也可以支援一些第三方的软体格式。那我们强调就是它现在用的就是德国 NVN 的影像处理核心。那接下来我会请博贤介绍一下关于 Video Server 还有一些定向影像 Objective Image 的介绍。先。
好，那赵军跟大家说明的是他利用卫照跟航照的一个在 ArcGIS 环境当中的测试的结果嘛，但我们晓得，其实在现在的 ArcGIS 的环境里面呢，我们因为截取影像的方式变得更多元了，所以事实上我们会预期它有更多的处理功能。除了卫星跟飞机之外呢，我们可以用 UAV， 我们可以派出车辆，我们甚至人手一个手机或者一台 GoPro 都可以去收集各式各样的影像回来，有些甚至是360的影像或者环景的影像，那也有可能是街景的照片，甚至我们谈到的是一段这样的影片。而这些装置在收集这些影像或影片的时候呢，其实都会记录一些 GPS 的资讯，此外还会记录照片拍摄的一些参数。那有了这些东西之后呢 ，Craig 刚刚有提过，在 ArcGIS 的环境里面呢，我们可以透过 Oriented Image Data Set 来去加以整理它，那它就可以成为我们 GIS 资料的一种辅助的资料来源。在这上面呢，我们可以进行一些量测或者是图真资讯的收集的动作。比如说呢，我们可能会用手机去拍一些照片回来。那这些照片呢，当我们把它整理在我们的 Oriented Image Data Set 之后呢，如果你把它加到 ArcGIS Pro 来，它可以告诉你每张照片拍摄的位置，以及它拍摄的方向，以及大概照片涵盖的范围。当你点击每张照片的时候呢，可以去个别检视它。那透过雷达图也可以大概知道这个位置还有没有其他的照片也拍到相同的内容。那此外呢，因为有这些参数的关系，如果各位呢在你的照片上面去点一个点，对应的地图上的位置也可以借由相空间跟物空间之间的转换，来去告诉你。那这个呢就可以辅助我们在了解 GIS 的资料的时候呢，成为一种另类的资料来源。那刚刚我们有谈到，影片也是我们可能收集到的一种新的资料来源。那透过 ArcGIS 的 Video Server 呢，我们有办法把各位的影片变成串流的Web Service 网际网络上的服务，让各位呢在你的 ArcGIS 的环境当中呢搭配它来使用。那目前呢，我们可以在单机版的 All Source 或者 Pro 上面，不论是直接读取影片，或者是接串流的影片，让它成为跟地图搭配使用的一种资料来源。那也可以借由新的Excalibur 这样的 Web App 网页上的一个应用程式呢，来去辅助用。那如果说我们今天是在 Pro 的环境里面去使用它的话，那文大的陈志远老师协助我们拍摄这段的影片。那就像刚谈到的，因为现在这段影片里面呢，会包含了 GPS 的资讯还有相机拍摄的参数，所以 Pro 是有能力帮各位解析成告诉你在地图上面对应来讲，每一帧画面它拍摄的大概对应的那个地图上的范围是哪里。那你也可以不一定要把它只搭配地图来使用。如果你搭配的是一个 3D 场景的环境的话呢，再搭配合适的 3D 资料去进行显示。比如说，如果今天是一个紧急灾害的事件发生的时候，当地的人只要出动一台空拍机拍这样的影片串流回来，那办公室就在中心的人呢，就可以了解到影片它所拍摄的位置大概在何处，那去做出相对应的一些应变的动作。所以当我们有更多的来源可以提供我们更多的影像的时候呢，我们当然会希望这些东西可以的话， 跟我们的 GIS 环境来搭配一起使用。那刚刚谈到的是在单机上面 Pro， 我们去用这样的影片的内容。那如果今天呢，各位使用的是一个 Web 环境的话，其实我们有一个现成的 Web App， 一个网页的应用程式叫 ArcGIS Excalibur， 就把这些功能呢，试着帮各位把它整并起来了。所以呢，在 Excalibur 里面呢，除了一般的检视影像，不论是卫星影像或航空影像之外呢，如果搭配了我们刚刚谈到的 Oriented Image Dataset 以及我们的 Video Server， 我们呢就可以在这上面呢，去再更进一步的去做其他的事情。比如说呢，交出一张影像之后，因为我们现在有GeoAI的功能，所以只要我们载入合适的模型，那我们就可以从影像上面直接去帮我辨识出飞机出来。那因为我们有 Oriented Image Layer， 我们就可以从照片上面去辅助定位，去了解该地的资讯。那如果这个资料来源是影片的话，也可以做到类似的效果。那甚至于 Craig 刚刚也有预告过了。接下来我们会希望能够把 Pro 的 Model Builder 把它搬到网页上面，让各位可以去使用。那各位就可以想象一下，你接下来很多分析的工作之前只能在 Pro 去自动进行的，现在也可以在网页环境里面流线化来去帮你完成这样的分析的任务了。所以呢 ArcGIS 对于这些影像或影片的使用呢，将会有更多元的功能呢，期待能够提供给各位来去使用。
Hey, Thomas and Chen are truly working in an exciting area. Now, you may have noticed how 3D is seamlessly part of the ArcGIS system, including in imagery, and that's incredibly important to Esri and perhaps to all of you. Esri is working across the platform to improve our 3D data creation and editing capabilities, and to have great visualization and in Pro and in the web. We have introduced enhanced 3D tools for modeling, exploratory analysis, and geoprocessing. Features like flood simulation, time-enabled 3D layers, and support for 3D tiles bring significant benefits to your work. We have also made great advancements in immersive experiences using extended reality and integrated game engines into ArcGIS. The ArcGIS 3D system offers a service-based architecture that many of you are leveraging to create living digital twins here in Taiwan. Perhaps one of the best examples of a 3D GIS system of record that I have had the privilege of supporting is ePlanner, an ArcGIS system developed by the Urban Redevelopment Authority of Singapore. Together with the National Parks Board of Singapore, they presented their work to an international audience in July this year. You can see here in the photo, this is during our own rehearsals. And they have been kind enough to allow me to share their work with all of you with some of my insights today. So the Urban Redevelopment Authority and National Parks Board in Singapore collaborate to plan and operate Singapore as a city in nature. Visitors and residents of Singapore alike will recognize these familiar scenes of an urban environment nestled amongst a natural landscape. Visitors to Singapore, perhaps some of you, also recognize it as a thriving modern metropolis with world-class infrastructure, a dynamic economy, and a vibrant living environment. But Singapore has a challenge. It is a low-lying island located only 1 degree north of the equator in the tropics, and it is hot, wet, and particularly vulnerable to climate change, including through rising temperatures and sea level rising. In fact, climate scientists have projected that Singapore would become even hotter, with temperatures rising between 0.6 degrees Celsius and 5 degrees Celsius by the end of the century if we do not act. In part, this motivates Singapore to take firm action in building a sustainable future with the Singapore Green Plan, a collection of strategies which are aligned with the UN's Sustainable Development Goals. One of these strategies is to ensure Singapore is truly a city in nature, where residents continue to enjoy that livable, sustainable, and climate resilient city. Now, to achieve this vision, Singapore is taking a systematic approach to preserve natural capital and create greenery at different scales within the city. At the macro level, Singapore has already set aside more than 20% of its land area to preserve tropical rainforests and mangroves. At the next level, Singapore has also developed more than 400 parks and gardens by design to provide every household access to greenery within walking distance of their homes. Along Singapore's streets and roadways, landscaping is also used to provide shade and a network of ecological corridors connecting our key biodiversity habitats. At the development level, greenery is also incorporated through the Landscaping for Urban Spaces and High-Rises policy that requires new developments to replace greenery that is displaced during construction. Some of Singapore's buildings are so lushly covered that it is hard to even see the buildings. But building a city in nature is not just about adding trees. A biophilic design restores natural habitats to allow local biodiversity to thrive, such as the native Raffles-banded langur. Planning and operating a city in nature requires an urban systems approach integrated with close collaboration between multiple agencies and partners like the URA and NParks. They leverage geospatial technology to build business-focused, enterprise-grade systems to plan and operate a city in nature. Today, I'm going to focus on URA. URA has been leveraging 3D technology since 2010 for data-informed urban planning and design. They have amassed a rich repository of 3D data across the entire country. This has been achieved in careful cooperation with other Singapore government agencies and commercial providers. This type of data and systems is known by many names throughout the world, including digital twin, smart city, and virtual city. And as many of you already know, producing this type of visualization that you see here is only possible if there is cooperation between the different owners of the data and powerful software systems to bring the data together. And of course, working with 3D data is complex. The files are often huge and come in a multitude of formats that require a variety of specialized software. However, by leveraging ArcGIS technology, URA could work across all these data sets. They brought together a talented group of young developers and 2 years ago started building a 3D system of record. It's accessible through an intuitive web-based platform called ePlanner. And I'd now like to show you a video of Chun Xiao and Chin Wen demonstrating ePlanner in July this year.
This is ePlanner. We built this customized application on ArcGIS platform that now serves over 1,600 users across more than 40 government agencies in Singapore. By integrating our systems with ArcGIS Enterprise Portal, our users can view an island-wide 3D model of Singapore through just their web browsers, as you can see here.